earlier, back when we did triangle congruence, we had 5 ways we could show that triangles were congruent. They were side angle side, side side side. What else? Yeah, I said that one. Side angle side, side side side, angle side angle, angle angle side, and hypotenuse leg. Right? We had 5 different theorems or postulates that helped us prove that triangles are congruent. What's the difference in congruent triangles and similar triangles?
It's going to go below, the vertex will go.
How different are they?
It will touch it when it's going down. And
Specifically, how are they different?
you know, kind of see that in your mind? Okay.
It's on your notes from yesterday. Top of the box. Angles are congruent, but sides are proportional. They are equal ratios. Okay? So, for similar triangles, the angles are still going to be congruent, but your sides will be proportional. So, today we're going to show that triangles are similar by angle. Okay? So, angle is exactly what it sounds like. If 2 angles in one triangle are congruent to 2 angles in another triangle, then you can say the triangles are similar. You can't say that they are congruent because remember, similar triangles have proportional sides, not congruent sides, right? So if we have 2 angles congruent to 2 angles, we don't even have to find the third angle. If we know 2 angles are congruent to 2 angles in another triangle, then we can say the triangles are similar. So in this one, obviously this triangle is larger than this triangle, so they're different sides, different lengths of different sides. And it's marked angle J has the same amount of marks as X, and K has the same amount of marks as Y. So since those 2 angles are congruent, I don't even have to know the measures, but I know that they're congruent, then I can say those triangles are similar because of angle. Okay? Now, again, the similarity statement needs to match up. J goes with X because they have the same amount of little arc marks. K goes with Y, so that means L and Z have to be congruent. Okay, so similarity statements are congruent, are important in the order. And remember, just the squiggle with no equals means similar, not congruent. Got it? Okay. So here's an example. I'm frozen, aren't I? Froze. Hide. Scroll. I'm trying to scroll. What the heck? Sorry about that. Okay, so here's an example. Y'all just watch, because it's going to take how long to write down this for us to do it, okay? Are these 2 triangles similar? If so, write a similarity statement. So, are they similar? How can we figure out if they're similar or not? I need to have 2 angles congruent to 2 angles, right? Well, right now, I know these are right triangles, right? So, I already know that angle D is congruent to angle G, right? Because they are both 90-degree right angles. So, how can we figure out if any other angles are similar or the same? But they have measures, right? Yes. So separately do that, right? 26 plus 90 and subtract from 180 will tell me the measure of angle E. Can y'all do that for me? What's the measure of angle E? 26 plus 90. Or actually, I can just do 90 minus 26, right? Right? Congruent complements theorem. 90 minus 26 is how much? 64 degrees. Whoa. So that means angle K is what? 26 degrees. So are they similar? Yes, because the angle similarity says if I have at least 2 angles congruent, then those are similar. So I have to write a similarity statement. So that means I need triangle blah, blah, blah is similar to triangle blah, blah, blah. So let's just start with C. Angle C is I'm trying to write a C. Angle C is congruent to what angle in the other triangle? K. And D is congruent to what? G, and E is congruent to H. Pretty simple, right? Any questions on that? So we just did the triangle sum theorem to subtract from 180 to find our missing angles, and then we could see which ones match up. Pretty easy? Okay. Can we show that these triangles are similar? This is a triangle inside of a triangle. Do y'all see that? We got the smaller one right here. It basically chops off the bigger one. Okay? So we can see one of them is definitely smaller than the other because it's inside of it. And I know that angle B right here is 52 degrees and angle C right here is 52 degrees. So that's one pair of congruent angles. Is there another pair of congruent angles? Yeah, angle A, they both have angle A, right? And angle A's measure is the same for both of them. So I could say that angle A, it says show, don't it? So show is basically tell why you know. It's not necessarily a proof. Okay? So if it says show, then you just tell why you know it. So angle A is congruent to itself. And if you want to use a property, that's reflexive. So now I have angle B and angle C are congruent. Angle A and angle A are congruent. So therefore, are those triangles similar? Yes. So let's just write the angles then. So angle A goes with angle A. B goes with C. So that means E goes with D because of what reason? The angle-angle similarity postulate. Okay? So a showing is basically stating what you know and why you know it, right? So I kind of did a proof here. Not really. Right? I just showed what I know. Okay, good job. So if it says show, you're not going to say yep. Does that make sense? You're not just going to say yes. That's not showing. Does that make sense? So that doesn't mean you have to do a whole table proof, but give some kind of explanation. Make sense? All right. Boom. Y'all draw this one. Draw this one.
It gets very like, it's frustrating when I tell you, like, I want things done a certain way because y'all never factored before unless you're eighth grade people really ahead of the game. And they also how to factor in eighth grade if you can correct it. But I don't think that happened because there are no eighth grade standards last all year long.
So again, I want to show that triangle SVR, which is this left-hand side triangle, is similar to triangle UVT, which is the right side triangle. Now, what do these little arrows right here mean? Those lines are parallel. So don't I have angle pair relationships congruent to each other when I have parallel lines? I sure do. I sure do. Now, all I need to do is show that two angles are congruent, right? Two pairs of angles are congruent to each other. Can somebody tell me a pair of angles that are congruent to each other? T and S. Oh yeah, T and R are. T and R are. Okay, so angle T is congruent to angle R because of why? Yeah, because of alternate interior angles. All right. Likewise, I could say S and U, right? By the same reason, right? But what's here too? Vertical angles. So I could say. So this one I actually have a lot of information I could go with. So angle SVR is congruent to angle what? TVU because of vertical angles theorem. And then I can say triangle SVR is congruent, not congruent. They're not congruent, are they? They are similar to triangle UVT because of the angle-angle postulate. I got two angles. If I've showed two angles are congruent to two angles, then I can say that the triangles are similar because of angle-angle. Any questions about that? Okay, so if it says show, that just means it needs some explanation, right? So it's kind of like a proof, just not as complicated as proof. Is everybody okay? So if I wanted to, I could, instead of using vertical angles, I could have used alternate interior angles here, because I just have to show two pairs of angles congruent. Does that make sense? Okay, good job. Okay, let me shrink back. Question. This is back to like the first example. Very similar to the first example. So this one didn't say show or anything fancy like that. It just says, are they similar? How can I determine if these are similar? Yeah, if I have two pair of angles congruent, right? How can I find these missing angles?
19 cubits combined for 49 missing sides. And that's
How could I find missing angles?
not including anything after that.
Could I find angle E? How? Yep, because these three make a triangle, right? So all three of these must add to make 180. Well, since this is a right triangle, these two have to add to make 90, don't they? Yeah, so one way I can find the measure of angle E is say 90 minus 31. And what is 90 minus 31? 59 degrees. Well, neither one of them. So this is a right angle, isn't it? Angle F down there has to be, because that's a linear pair, right? So if one's 90 degrees, the other one has to be 90 degrees. How do I find the measure of angle D? I can do 90 minus 67, which is what? 23? Are these triangles similar? Well, I have one pair of congruent angles, right? Do I have two pairs of congruent angles? No. So I cannot use angle to say that they're similar, because none of the others match up. Correct? So you're just going to say, not similar. So any questions there? So if you find all your missing angles using triangle sum theorem or congruent complements theorem or any of those, then if none of them match up, they're not similar. Plain and simple. So any question on showing that triangles are similar by the angle-angle postulate? That's it. You need two pair of congruent angles in both triangles to say that they're similar by angle-angle. Tomorrow, we're going to do side, 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 and side angle side similarity. So there'll be a little bit more work till tomorrow, but that is actually the end of notes for today. Yep, nothing left. Have a good day.